We okay? Method 2. We're going to basically do the same steps, but we're going to shake off the idea that we need to be in X and Y direction. Now, here's my warning and my caveat. If you are stuck in X, Y direction and you're like, I'm already coping with so much, please don't make me do anything that's not in an X, Y direction. It's absolutely fine to do method 1. Method 2 is along the plane. We have absolutely no reason not to resolve my forces in the direction of the plane. I can even turn it so that it looks like they're not like that. If I take this as my orthogonal directions, T is already there. Up the plane, I've chosen to make it the positive direction. N, or force N if we want to call it force N, is also at 90 degrees. Yes, no resolving required. Then we get to mg. And it causes us a little bit of issues, because mg needs to be resolved into a component in this direction and a component in this direction. Let's come over here. Here's what I've got, and here is what I want. I know I've drawn them beautifully over there, but they're not actually like that, are they? They are like this and this. Do you agree? So they are like this and this. Where this is in the T direction, well, actually, T is that way, and this is in the N direction. Are we okay? Where are my angles? One of them 60, one of them 30. Which one is which? Let's have a look. Here's my plane, so this one is parallel to my plane. What does that make this angle in here? 30, this one here. And then that makes this one here 60, or this one here 30. Either way. So either this one here is 30, or this one here is 60. Which one do we want to go with? 60. What does that make my T direction? T direction, which is this one, it's going to be mg. Do you want me to draw this big? Yes? Eric's like, yes, please. Let me draw it big. Here's my mg. Here's my T direction. Remember, T was up that way. Here's my N direction. N was up this way. And that's my right angle. We've said this one here is 60, and that's the one we want to go with. What is this T component going to be? mg cos 60. There we go. And what's this one? Now, why would we do this? I know it's like a bit of a brain. Your brain's going, what are you doing to me? But over here, this is pretty lovely, isn't it? Compared to T's and N's being all over the shop. What's cos 60? Half? And what's mg?
50.
So what's this?
25.
So when I resolve my components in the not the x direction and not the y direction, when I resolve them in the t direction and the n direction, bad notation because I have a force that's t and n, so let's call them something else. If only I had some unit vectors that were orthogonal to each other and in whatever direction I wanted them to be in, what would I call them if I had letters to do that? I and J. I don't care which direction those are in. Do you agree? Call them I and J. Now in the I direction, which is this one, I've resolved my forces, and guess what? T equals 25. It's there. Do you agree? Didn't even have to get to the next column. If I resolve them in this direction, what's sine 60? 3 on 2 times 50 gives me 25 root 3. In this direction, is this easier?
Got a question here. In the exam, you need to. Is it necessary for us to say like the net loss is equal to 0 in order to get a mark?
Yeah. Yes. Not in order to get a mark. To communicate what you're doing, yes. You can't just magically go, especially for this method. Oh, T is 25. I'm good to go. I don't need to show any working. Where's your working here? It's the diagram. And the diagram, and that's why I was happy to draw this one bigger. The diagram takes all the work out of it for you, and then it falls out. And it's so much easier to do it in a plane that works for us. This is why we taught you unit vectors. This is why we've asked you to do projections and make them into any direction we want them to go into. So that you can do this in 2 steps. Pretty cool? This is a bit of a brain tease. Draw your diagrams big. All right, make sure you get your angles the right spot. If you don't, you're probably not going to lose a lot of marks as long as your diagram makes sense. You won't lose them all anyway because you've shown a lot of understanding.
So if a question is not asking for a diagram, but you ask you to solve something, but you have a diagram, you still get the mark even though you don't have any calculation.
I do have calculations, but where are my calculations? So I refute that I have no calculations. Do you think I've explained this clearly? As long as we've explained it clearly, that's where the marks come from. My pro tip on exams, if you're doing a vector question other than the most basic arithmetic in a multiple choice, if you're doing any type of vector question like this and you don't have a diagram, you're probably going to be going wrong somewhere and you won't be able to recover those marks. Okay? Diagrams. Have I said it enough this topic?